Okay. Number 9. 30, 60, 90 or 45, 45, 90? 30, 60, 90, great. Okay. Now I'm doing this problem right before your quiz. There is not one of these on your quiz. Do not put a 30, 60, 90 or 45, 45, 90 on a Pythagorean identity problem. That would be bad. The one on the quiz, you have to do Pythagorean theorem. This is not that. So anyway, okay, half root 3 over 2, 1. And this one is great because it's in quadrant 1. And sorry, I got you. Yes, but what I was going to say is it's in quadrant 1 and they're both positive. So that's good. Thank you, Ben. Okay, so a reminder, tan is y over x. And that part you're going to need for Pythagorean identity. Just saying, you need to know the y over x bit. 1/2 over root 3 over 2. And when you're doing the tan, the denominators should always cancel. And then you just leave it like that and walk away and you're fine with it. You're fine with the way that looks. You're okay with that? That looks acceptable to you? What do you do? No, he's not wrong. He's working on the online, and if it's two things, it's conjugate. If it's one thing, it's rationalized. You're not wrong. You're not wrong. Anyway, okay. No, he's okay. When you have two things in the like a binomial in the bottom, the way that you get rid of the square root is you multiply by its conjugate. The process of doing that is a verb called conjugating. That's what he's saying. Anyway, square root of 3 over 3 was the answer I was going for there, regardless of what it is. Okay, now if you guys could find number 13, please and thank you. Okay, now this type of problem is on your quiz, so this is the whole reason I wanted to do um, the warm-ups first. Gosh, Mrs. Talby, you're a nice lady. Okay, so number 13, what is A? 3. What is B? 2. 2 pi divided by 2 is pi. Okay, now pause. What is pi? How many boxes on this graph paper? 1, 2, 3, 4, 5, 6. Perfect. Okay, what is H? Positive pi. Great job. Make sure to switch the sign. And K is 0. And you can do this if that helps your brain. Okay. Midline is 0, which is already bolded, so I don't need to dash that, but I am going to dash 3 and -3. My amplitude lines. Everybody okay with the lines? Okay, now what's the locator point for cosine? Yep. Okay, but wait, what would it be? What would the locator point be for this one? Just in case this is the one you got on your quiz. HK, right? That's one of the things I asked you to memorize. HK, H comma K plus A. Okay. H is pi, K is 0, A is 3. So pi 3 and circle. Okay, you guys good so far? On your last test, by the way, the direction said circle your locator point, and I think like 2 people did out of the whole class. If you could circle your locator point, I didn't take points off. It just makes it so much easier for me to tell like if you know what you're doing. Okay, anyway, the period is 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. I'm just gonna put my ending dot slightly off the graph paper. It's no big deal. And this is positive cosine, which looks like this. Top to top. Good? Everybody good? Okay. And then in the middle of those, it will hit the bottom. And then in the middle of the first two, it hits the midline. In the middle of the second two, it hits the midline. And I'm done. On your quiz, though, it does say graph as many cycles as you can, which means you need to go forward and backward. Just keep the pattern going. Okay. Anything you want to ask about that before we start the quiz? Okay, everybody put everything away except for a pencil and a straight edge. Make sure that your phones are up, please. I'm going to check that in a second. For permutation and combination.
I guess it's already fine, right? Base. What did you have 1.5? It's gonna go up to an 89 because I have. You guys put yourself a lot. Everything but hard point. So I can 100%. You put your assignment that was 89 right? And that you are. No, no, this is that's taking my password. Yeah. So, right, I get it. Step, the only thing, and if you all, the 89.9.
Guys, stop on the wall because let's see back.
Where's your product? Yeah. No shampoo. No shampoo.
Hold on. Wouldn't it be great if I left that on the screen?
I think you should.
I'm not.
And leave like an answer sheet, right?
I should slip and leave that. You hearing me over here?
I think that'd be smart. I think that'd be very educational. You learn a lot. Yeah. You know what I mean?
Where's the graph? Unlocking. I think it's 25th. I think it's. Okay, last quiz went out at 41. So I'm expecting them to be turned in by 56. Geometrics today, and I don't know how much you guys remember about geometrics. Multiplication, just keep in mind that I'm going to say multiplication, but I could be multiplying by a fraction, which you guys might think of as division. But I'm going to still think of that as multiplication. But I'm going to start out with a very, very simple one. Just so we're all on the same page. And today I'm going to do something really spicy that I would not ask you to do. I'm going to derive a formula. We don't do a lot of formula derivation because students get lost in the middle of it. You can attempt to do it today. If you get lost in the middle of it, that's okay. Because the whole point is to figure out what the formula is, and then we're gonna have a formula at the end, which everybody will be fine with. But I'm going to attempt to show you how to derive it today, which is kind of cool if you can follow it. Again, if you can't follow it, don't freak out. It's okay. It's just, I want to show you how something works. But okay. The first thing I want to say is geometric sequences and series are number patterns formed by repeated multiplication of a common ratio R. So R is the multiplier for geometrics. In this example, can you guys tell what R is? Yes. R is 5. And can you tell what term 0 would be? 2. And there are 2 different ways to write the equation. Shocking. There's a term 0 style and a term 1 style. With geometrics, you're going to see the term 1 style a lot because term 0 is often messy, like a decimal or fraction or something gross. Well, most of the time you're going to see geometrics in terms of term 1. You'll get really used to seeing that as we go through the chapter. So for term 0, it's T of n equals, and remember, geometrics are exponentials. Exponentials are a b to the x. A is term 0. B is the multiplier, and then to the n. Okay, now what do you do? That's old stuff. That's like the math 1 style. Now what do you do for term 1? What you do for term 1 is you start with t of n still, and instead of putting term 0, you put term 1, and then you put the multiplier, and then you back up n a spot to balance it out. Does that make sense for what you guys know about arithmetics? Do you remember how we backed up the n 1 spot and then started at term 1 instead? This is the same thing. It's just that the format is ab to the x instead of mx plus b. Okay, term 0, I think is easier to plug into. And I'm going to give you a little foreshadowing. Easier to log. Think about how would you solve for n? Hit it with the log on both sides. These are squirrel in the tree problems. Okay, and then why is the first term equation better? You don't have to work backwards to find term 0, which I said makes a lot more sense for these because you have you have a bad, like a fraction decimal gross term 0 a lot of times. Okay. Last thing for number 1, we're going to do 2 things. We're going to take this equation. Let me. Second. Okay, now I have a very important question. For C, is this equation using term 0 or term 1? Term 0. How can you tell? Exactly. So it's just plain n in the exponent. So that means that it's term 0. Okay, so what I'm going to do is I'm going to take my pink pen and I'm going to say, okay, that means that term 0 is 18. And I'm going to make a picture like this. Does that make sense to you guys? So since this is plain n, that means 18 is term 0. So I'm going to write it in pink with a line under it. Okay, so if that's the case, then what is term 1? 54. And then 162. And then 486. And then there's my picture for that. Okay, last thing I want to do for C is now I want to take this sequence and write my equation in terms of term 1. Okay, so what will change? T of n equals. What do I put first? 54 times 3 and minus 1. Okay, do you notice how in some of them I just write a times and in some of them I put parentheses? You're going to see it both ways. You can do whichever one you like better. It doesn't matter. I just do both. I don't know why. Just whatever the situation is. Sometimes I feel like doing parentheses, sometimes I feel like doing time. But don't get tripped up by that. It's the same thing. You might be thinking to yourself, stop it, but I just cheat and multiply those two things and put that in the front and change that to n minus 1. Yeah, Yes, you can. You could just multiply those two things, put that in the front, and then put n minus one. Okay. All right, 82. For 82, we need the book, which I failed to open because I'm apparently behind schedule here. Okay. This is one of my favorite problems because the guy in the problem is named Mr. Hanks. And I don't really think it's Mr. Hanks. I think it's Hank. So I'm just gonna picture Hank the whole time. Do you know who Hank is? Does anybody know who Hank is? Doc, the septicus in Scott. So just picture him, he's in like camouflage. Okay. With a record-setting lottery jackpot projected for new tomorrow, Mr. Hanks, or is it Mr. Hanks, is standing in a very long line to buy a ticket. The man behind him in line taps him on the shoulder. He doesn't have a shoulder. Taps him on the mantle. Good. I was just pretending that Mr. Hanks was the octopus from Finding Dory, because I thought that would be adorable to picture him standing in line for a lottery ticket. Yeah, he's not really Mr. Hanks. He's Hank. That is Hank. Let's pretend he's wearing his glasses. With Dory in a cup. It's the mission, the secret mission. Oh, can be in the coffee pot if you wanted to be in the coffee pot. Anyway. Hey, have you thought about how you'd spend the money if you want? Before Mr. Hanks can answer, the woman in front interrupts and says, first, you have to decide whether you want to get your winnings in one lump sum right away, or if you want to receive them spread out over time. You guys know this is real, right? If you win a really big lottery, you can get a lump sum, or you can get it spread out over time. Yeah, but they won't give you the whole thing if you do the lump sum. Okay, I'm sure that one option must be a better deal, but I haven't figured out which one. When Mr. Hanks gets home, he immediately goes online and learns that lottery winners do have a choice. Receive the winnings in a single payment of 51% of the jackpot right away, or spread payments of the jackpot over 20 years. He also learns that the jackpot is projected to be 50 million. He knows that if he takes the single payment, he can invest it right away and earn 4% annual interest on that money, which sounds like probably a good idea. I don't know how you can get 4% interest on anything anymore, but that's fun. If he chooses to receive the payout over 20 years, the lottery commission will invest the money for him. They guarantee to pay 1,500,000 in the first year and to increase the amount they pay by 5% each year. At lunchtime, Mr. Hanks walks into your class, yes, please, and asks for your help. If your team can figure out the difference between the totals for the two payment methods, Mr. Hanks will give that amount to your team if he wins the lottery. I know, Mr. Hanks is so generous. If Mr. Hanks wins the lottery and takes the payments over time, the amounts he will receive each year form a geometric sequence. What is the first term? What is the multiplier? Write an equation to represent the terms of his sequence. Okay, so this is saying the payments over time, which is this paragraph right here. Okay, they guarantee to pay 1,500,000 in the first year and to increase the amount they pay by 5% each year. Okay, what would the first term be? Yes, okay, so we're gonna say first term is 1,500,000, and then it says there's a 5% increase. Does anybody remember from math 1 how to take a percent increase and change it to a multiplier? Okay, so you go 100% plus 5% is 105%. which is 1.05. Great job. Okay, now I'm too lazy to go back and figure out what term 0 is. So I'm going to write my equation in terms of term 1. Do you see how helpful that is right now? So T of n equals 1,500,000 times 1.05 to the n minus 1. Okay. Apparently I only have through C. If Mr. Hanks takes the payments over time, how much will he receive in the 20th year? What should I do? Plug in 20. Ooh, okay. So that's 3,790,000. Okay. 3,790,425, and I'm sure Mr. Hanks is going to want his 29 cents. He's definitely going to want his 29. Right. I mean, he could invest that 29 cents. Okay. When you add up the terms of this sequence to determine the total over 20 years, you're calculating the sum of the geometric series. Show the geometric series. Okay, so we're going to show that two ways. The first way we're going to show it is by writing out the sequence with the plus signs, and then we're going to rewrite it into sigma notation. So does it make sense that the first term would be 1,500,000? Okay, so to get the next term, would be 1,575,000. Man, if Mr. Hanks can't figure out how to live on that. Okay, so remember, we always have to show the first two and the last one. The last one we calculated a minute ago. This is representing 20 years. So this is, I'm going to come back with my pink pen and say, this is year 1, this is year 2, this is year 20. And I'm also going to just show how I got my series. Okay, so last thing for number 82, make your capital sigma. What letter do you guys want to use? N? Okay, and we're going to start at term 1 and go to term 20. So we're starting at term 1, going to term 20. And then we put the equation here, which we already found. Done. Okay, now you guys do not know how to add this up without finding all 20 terms and adding them together. So the next thing I'm going to teach you is an easier way. Okay, I'm going to flip my paper over because I need a lot of space for 83 through 85. So 83 through 85 is my derivation problem. You're supposed to do it in 3 separate problems, but I don't find that that flows very well. So I combine it all into 3 problems, all 3 problems into 1 problem. And this is where I'm going to derive the formula for the sum of a geometric series. Again, this is really spicy stuff. If I lose you somewhere in the middle of it, it's okay. No need to even tell anyone. Just write down what I'm writing. But if you like it, that's cool too. So this is saying the sum of 6 terms. Term 1, term 2, term 3, term 4, term 5, term 6. And I have that there for a reason. Okay. First thing I'm going to ask you is what is the multiplier? This is almost the same one we were working with before, right? The multiplier is 5. And my strategy, which you will see why I'm going to do this in a second, is I'm going to multiply the entire series by 5 by the multiplier. Okay, so the first thing I'm going to do is say 5 times the sum of the 6 terms. And then I'm going to multiply each one of these by 5. So this one becomes 10. And it's going to make sense in a minute why I'm doing this. This one becomes 50. Okay, can you see how I took each one and multiplied it by 5? So I multiplied by 5 on both sides. Okay, now I'm going to subtract the original one. This is like some Gauss level stuff here. Except for that I didn't come up with it. Okay, now on this side, this is like 5x minus x. What's 5x minus x? 4x. So we have 4 times the sum of 6 numbers. And on this side, I'm hoping you see that some stuff cancels out. Because when I'm subtracting everything. So, yeah, so 10 cancels, 50s, 250s, 1250s, 6250s. Okay, so the only thing that's left is this guy up here and this guy up here. So 31,250 minus 2. Okay. What's wrong? I know. Okay, so the sum of those 6 numbers is 7,812. If I went up to the original problem and added those 6 numbers together, it would be 7,812. You're like, Mrs. Talbot, that was the most roundabout way to find the adding up of the 6 numbers. Okay, I'm gonna use that as a concrete example, and I'm gonna go abstract now. Are you ready? Okay. S sub n. So we're going abstract now. We're going to try to apply this concrete example to a problem with a variable in it. Okay, let me just explain what I wrote down. So, do you guys remember how I said yesterday when we were doing C? And I was like foreshadowing, this is gonna come back. And you remember how it ended in the equation? The last term was actually the equation. Okay, so this is saying you have some number of terms. This is the first term, they multiply by 5, and you don't know where it ends, but you know that they all follow this pattern. Okay, let me say that again. So you're adding up some number of terms. It starts with 2, it multiplies by 5, and you don't know where it ends, but it keeps going in that pattern. So wherever it ends will continue to be in that pattern. Okay. So now we're gonna do the same thing we did in our concrete example. The multiplier is 5, so I'm gonna multiply this by 5. Okay, and what will change here? What will this become? 10 plus 50 plus 250 plus 1250 plus 6250 plus, okay, and then yes. Okay, so how do I want to write this? So I'm gonna write it like this. Does that make sense to you guys? I just multiplied that thing by 5. Okay, now I'm gonna subtract the original one. Yeah. Because multiplying by 5 will make these numbers exactly the same as these numbers. Yeah, just because that's the growth. Whatever the growth is. And the reason is because I want the stuff to cancel like it did before. So I want the numbers to match. Can you guys tell me what this side will be? Wait, this side will be 4 times the sum. Okay, and then let me do my canceling thing again. Okay, now we don't care what all comes here. We know from our previous work that the only thing that's going to be left is this and this. Does that make sense to you guys? No. Hold on. So I just wrote that big thing minus 2. Okay, now this is the spiciest part of the problem. And this is the part where I'm hoping somebody in the room will see it. What can I do to n minus 1 when I multiply it by 5? Let me ask you again. What can I do to n minus 1 when I multiply by the multiplier? Okay, do you notice that multiplying by the multiplier moved everything down a spot? Okay, yeah, exactly. Barrett's got it. the multiplier and the -1 cancel each other out. Because he went down a spot and up a spot. The up a spot and down a spot cancel. So now I have 2 times 5 to the n minus 2. What's wrong? Okay. And then okay. This is enough for us to derive our formula. Okay. This is our formula. Okay. Tell me, what was the 2 in the very original series? Look back up at the top of the page or the top of the term 1. And what was the 5? And then again, what was the 2? Okay, and then how did I get the 4 from this? Yep, r minus 1. Okay, first term times the multiplier to the number of numbers minus first term over multiplier minus 1. And if I lost you anywhere in my derivation, that's okay, because now you have the formula. Okay. Number 86. We're going to use the formula. Okay. We need 3 things in order to do our formula. I'm already getting irritated. I might have to assign seats. Okay. Looking at this equation, what is the first term? 30. And you can tell it's 30 because this is n minus 1. Okay, what's the multiplier? 1.2. And how many numbers am I adding together? 30. Okay, sum equals 30 times r to the n minus 30 over r minus 1. Okay, this is not a one fell swoop situation. This is a parentheses needing situation. If you're doing these problems on the calculator, you need to do that and that. If you want to do one fell swoop, I usually I hit enter after the top and then divide with the parentheses, but whatever you want to do is fine. So 30 times 1.2 to the 30 minus 30 divided by 1.2 minus 1. You guys see my parentheses around the top, parentheses around the bottom. If you want to do one fell swoop, that will work. 35,456.44. 45. Do not be freaked out by the fact that sums are decimals for geometrics. It happens all the time, especially when your multiplier is a decimal. Okay, now scroll back to Mr. Hanks. Scroll back to Mr. Hanks. Mr. Hanks was 82. Okay. Put in equals. This is number 82. You'll have enough room. You'll be fine. Okay. First term. Times R. Whoops. And you guys don't get antsy. I don't know if you read the stamp sheet, but we're still doing notes after this. You look like you're antsy already. The notes are quick though. This is not notes. Okay, try this in your calculator, please. Put parentheses around the top, parentheses around the bottom. I mean, it's gonna be a lot of money. I didn't follow my own advice. Okay, is Mr. Hanks rich? Oh, yeah. 49 million. Okay, so what's your recommendation? Should Mr. Hanks take the payments over time? Now, keep in mind, if he's an octopus, what really are his expenses? Also, he has his royalties from the movie he made. So I think we should take the payments over time. I mean, if an octopus can't figure out how to live on $1,500,000 a year, so what's he buying? Shrimp? Like a lot of shrimp? Shrimp in bulk? I suppose that could be expensive, but 1.5 million expensive? Probably not. No. He needs new sunglasses, so he can blend in. He doesn't need that. He's got camouflage. No, it's true. It's true. No, I don't know if you can get a tentacle grafted on. You guys have seen the movie, right? Okay. Okay. You're just all business today. Find a spot to put your notes, please. This is the notes. It is work Wednesday. I don't know. It's this big when it's done. This is the done. While you're setting up your notebook, I have to tell you, I am usually, I hope you guys know that I'm a pretty fast grader, but my adult children are coming over tonight for dinner, and I don't want to sit and grade papers in their face. My daughter-in-law, she's gonna have a baby in like 5 weeks, and they just bought a house, and I like want to hear all the things they have to say. So I just want to tell you, I might not be as fast as you do, but I just don't want to be, well, I know, I don't want to be like a jerk and like grading papers in front of them, like while they're trying to tell me stuff, so. I'm gonna do my best, but I know. But like, I just wanted to tell you, if there's nothing wrong, if it's not immediately. I'm super excited for them. They're so cute. I keep buying things, like, I got a bucket hat with Mickey ears that's like 6 months size. I know. And I got like, well, she's a girl for now. But sorry, that's just my life experience. Um I have a trans kid, but I got this little like Jack Skellington suit that says like my first nightmare or something on it, and then it has like a Jack Skellington hat. Yeah, it's not my biological, but yeah, it's so fun. So I just have so much stuff in my Amazon cart. I can't wait to get them things that are like noisy. Oh, it's gonna be great. If they made one. You know what I'm doing at lunch, Sean? Yeah, I could be grading quizzes.
I couldn't keep it up to them. But I can push that too. Oh, yeah. I've done those two.
Oh, you're talking about,
Yeah.
yeah. Okay, guys. Geometric sequences, number patterns, formed by, I bet you know this, repeated multiplication. And remember, it could be a decimal or fraction, which looks to you like it's dividing, but you need to think about it as multiplying by a fraction or a decimal. Um, Also, I want to give you a life tip. All of the ones that we've been doing, it's been very easy to figure out what the multiplier is. Sometimes you can't though. And my advice is to take the second term divided by the first term in case you can't immediately tell what the multiplier is, like if they're decimals or something. Do the second thing divided by the first thing to get the multiplier. That's just my little life hack for you. Okay, but on this example, it's very easy to tell. Times 2. Term 0 is 4. And term 0 looks like this. T of n equals T0 times R to the n. Look at now I'm going no parentheses. I don't even know what's happening. And then T of n, first term instead, times R, and then back up the train a spot. Term 1 one's better for this. It's easier. Well, I just mean, if these are not whole numbers, if this is like 2/3 or something gross, then this one's better. So this one is 4 times 2 to the n. And this one is 8 times 2 to the n minus 1. You guys have any questions about the two styles of equations? Okay, now we're going to do that sum formula. I'm not going to ask you to derive it again. I'm never gonna ask you to derive it again. I just do that one time. See, that's the beauty of deriving a formula. Now you have the formula, so you get to use it. I know. Okay, the formula is sum equals, and it also might say S sub n. So S means sum of n amount of terms, or it might say the word sum, either way. First term times r to the n minus first term over r minus what? Okay, so over here, we need to know three things to do this formula. We need to know the first term, the multiplier, and how many terms we're going out to. Okay, what's the first term in this example? 8. What's the multiplier? 2. And how many terms am I going out to? 16. See, it's not bad once we get the formula. Why? Are you guys okay with the fact that I only typed in the numerator? Because the bottom would be 1. Okay. Last thing. And it really is the last thing this time. I promise. I'm going to write my summation notation in terms of term 1 because that's what you're gonna see mostly with these. It doesn't matter though, you could write it with term 0. So in this problem, I'm going to use n. I told you the other letters you might see, right? H, I, K, T. I don't know why we picked those. I don't know. And then it's telling you it's going out to 16 terms. So term 1 to term 16. And then you put the equation right here. So that would be 8 times 2 to the n minus 1. Or you could do 4 times 2 to the n. That's it. That's it. We're done now. We still have 15 minutes.
You do?
Yes, 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 yes.
Okay, so you,
Yes, honey.
so you need the combination permutation from that, right?
Mhm.
That,
And then the digital escape,
oh, yeah, and then my.
and then the quick review. Okay, and then it starts at 10:1.
Okay.
So it should be 10:1 through 10:6.
Yeah. 6?
And then 21, 24,
Then.
51 and 53.
If you want to-
That was, you were absent for that.
I was absent.
And
But
then
I have.
19, 16.
Oh, there.
Yep, okay, and then you have today's,
Yes.
and then you said you have this homework too, or?
No, I don't. I have
Okay,
to do, I
okay.
have to do yesterday's stuff.
Okay, perfect. I didn't stamp anybody's homework for that, so you're all caught up though.
Okay. but-
I do stamps.
Yes,
I need the quiz
you wanna
review.
go water?
Yeah.
Last night's homework.
Yep.
That was yesterday's notes.
Mm-hmm.
Today's, and I was able to do today's homework in Access. Got nothing else to do. And then the note.
So if you could just manage to squeak out those 3 problems in the next 2 days, you would have no spring breaks. Just
Alright.
saying, just saying,
Thank you.
just saying.
All right.